This is activity 2 from lesson 9, quotients of sides within similar triangles. So in this activity, they start with a triangle and they give you 3 other scale factors. The first one is a scale factor of 1, so it's the same triangle, and then a scale factor of 2, 3, and 1/2. And the first thing to do is to complete a table where you multiply each of these lengths by the given scale factor. So if you multiply them by a scale factor of 2, then this length is going to be 14. 2 times 7 is 14. This length will go to 10. 2 times 5 is 10. And this length will go to 8. 2 times 4 is 8. So they're going to call this the long side, the medium side, and the short side. So a scale factor of 3 and a scale factor of 1/2. 3 times 7 is 21. 1/2 of 7 is 3.5 units. So 4 different sizes of this triangle. The long side, the medium side is 3 times 5 is 15, and 1/2 of 5 is 2.5, 2 5/10. And the short side, 3 times 4 is 12, and 1/2 of 4 is 2. So 4 different triangles, and then you list those lengths in the table. So this is the long side, the length of the short side, the length of the medium side, and the length of the long side. So I just listed those lengths. Now, before we found the ratio of the corresponding side going from one triangle to another triangle. So this is a scale factor of 2. So 8 divided by 4 is 2. 10 divided by 5 is 2. And 14 divided by 7 is 2. So we say the scale factor is 2, and we build that triangle. So now we're going to look at the ratio of sides within the same triangle. So for triangle ABC, what's the ratio? So this is a scale factor of 1. What's the ratio of the long side to the short side? Well, the long side is 7. The short side is 4. So the long side is 1 3/4 times as long as the short side. So 4/4 is 1. Another 3/4 left over, so it's 1 3/4 times the short side. How about the long side compared to the medium side? Well, the long side is 7 units. The medium side is 5 units. So the long side is 1 2/5. So it's 2 more fifths longer than the medium side. So that's the same as 1 4/10. So it's 1 4/10 as long as the medium side. And how about the medium side compared to the short side? Well, that's 1 1/4. The medium side is 5 units. The short side is 4 units. So it's 1 unit, 1/4 longer. It's 1 out of those 4 units longer. So it's 1 1/4 times as long, or 1 25/100. The next triangle, it's the same thing. It's 14/8. 14 out of 8, is the same as 7 out of 4. So 14 out of 8 is 1 3/4 times longer. So 14 is 6 units longer than 8. 6 units is 3/4 of 8. So it's 1 3/4 times as long. 14/10 is 1 4/10 times as long. And 10/8 is 1 1/4 times as long. So you might go through the math a little bit. This is 4/10. 14 minus 10 is 4/10 longer, so it's 1 4/10. This is 2/8 longer. 2/8 is the same as 1/4, so it's 1 1/4 times as long. The long side, the short side, if a scale factor of 3 is used, that's 21/12. Again, that's the same as 7/4. So 21/12 is 9/12 longer. 9/12 is actually 3/4, the same as 3/4. So it's 1 3/4 times as long, 1 4/10 times as long for the long side compared to the medium side. And the medium side is 1 1/4 times as long as the short side. So what do you notice? That these ratios of sides within the triangle. So let me go back for a second. Ratios of sides within the triangle. So this side is 5/4, whether it's scaled 2 times, 3 times, 1/2, or the original side. This this side, this would be the medium side to the short side, is always the same. That ratio does not change. And this is setting you up to make these calculations in the future where the triangles, instead of, this is not in a right triangle, but the triangles are going to be right triangles, and you're going to compare the vertical side with the horizontal side pretty soon. And you're going to start calculating something called the slope. Now this ratio takes you back to 7th grade. This ratio is called the constant of proportionality. So when you compare sides within the same triangle, and you compare them to similar triangles, those corresponding sides to similar triangles, that ratio remains constant. So it's the constant of proportionality, back from 7th grade, although the authors never say that. All right, so JKL, the long side, the ratio of the long side to the short side, again, it's 1 3/4. So no matter the scale factor used, that ratio of those two sides within the triangles is always the same because they are similar triangles. The long side compared to the medium side is 1 4/10, and the medium side compared to the short side, once again, is 1 1/4. So this is 2 1/2 to 2. Well, that half is 1/4 of 2. So it's 1/4 longer of 2 than 2. All right, so this is setting you up. We're going to look at these same ratios, but with right triangles pretty soon, and start calculating the slope, something called the slope.